Functions. Whenever a relationship exists between two variables such that for every permissible value of the first, there is only one corresponding value of the second, we say that the second variable is a function of the first variable. The first variable is called the independent variable. The second variable is called the dependent variable, since its value is determined by the choice of the independent variable. If we have the equation y equals 2x squared plus 3, I make up my chart to figure out xy values. X is the independent variable, y is the dependent variable. So I choose values of x and I solve for y. When I choose a 1, it's going to be 2 times 1 squared plus 3, or 2 plus 3, which is 5. When I choose a 0, it's 2 times 0 squared plus 3, which is 0 plus 3. When I choose a 2, it's 2 times 2 squared plus 3, or 2 times 4 plus 3, 8 plus 3, or 11. Write in function notation. F of x is read f of x, so you do f with parentheses around the x, so it's a function in terms of x. It's equal to 2x squared plus 3. F of 1, this is the same exact equation I had up here, I'm just using function notation. F of 1 means I take the 1 and put it where x is, just like I did here. I choose a 1, put it where x was. 2 1 squared plus 3, so that's going to be a 5. So f of 1 is 5. F of 0, again, put the 0 where the x is. F of 0 is 3. F of 2, putting the 2 where the x is. F of 2 is 11. You can determine the value of a function in terms of literals too, meaning I can put a variable in as well. So f of x is equal to 2x squared plus 3. Find f of a. This time I'm going to put an a in wherever x is. So f of a is equal to 2a squared plus 3, which is 2a squared plus 3. So I took the variable in terms of x and the function in terms of x, and now it's a function in terms of a. I can also take the same function, f of x equals 2x squared plus 3. This time I want to find f of a plus 1. So I'm going to substitute a plus 1 this time for x. So f of a plus 1 is 2. Instead of x squared, I do a plus 1 squared plus 3. Now I have to solve it. So a plus 1 squared is a plus 1 times a plus 1. So I'll do that first. So distribute the a times a is a squared, a times 1 is a, 1 times a is a, 1 times 1 is 1. Combine like terms, a squared, a and a is 2a plus 1. Distribute the 2 on the outside. So I get 2a squared plus 4a plus 2 plus 3. Combine my numbers at the end. 2a squared plus 4a plus 5. So f of a plus 1 is 2a squared plus 4a plus 5. Given the function in terms of t is equal to 4t squared minus 5t, find f of a to the third. So I'm going to put a to the third wherever I have a t. This time I have a t in 2 places, so I just have to put a to the third in both those places. So 4 times a to the third squared, which is this right here, minus 5 times a to the third, which is this. When you're multiplying exponents, it's multiply the exponents. So 4, 4a to the sixth minus 5a to the third. These cannot be combined because they're not like terms. Let's try this one. G of x is equal to 3x plus 9. Find g of 4 over 3. So g of 4 over 3 is equal to 3 times 4 thirds plus 9. This 3 is 3 over 1, 4 thirds plus 9. So this is going to multiply numerators, multiply denominators. 12 over 3 plus 9. 12 divided by 3 is 4. 4 plus 9 is 13. So g at 4 thirds would be 13. F of t is equal to the square root t minus 4. So only that's under the root, plus an 8. And I want to find f of 8. So wherever I have a t, I put an 8. So it's going to be the square root of 8 minus 4 plus that other 8. So 8 take away 4 is 4. So square root of 4 is 2. I still have that 8. So 2 plus 8 is 10. Let's say I have that same exact one, but now I want to find f of x plus 4. So not only do I want to put a number in and a variable, I'm changing the variable as well. So wherever I have a t, I put an x plus 4. So it's going to be the square root of x plus 4 minus 4 plus the 8. X plus 4 minus 4, so this 4 take away 4 makes a 0, so that just equals the square root of 8. And then you add the 8. So the only thing under the root is the square root of 8 of x. F of x is equal to 2x squared plus 3. This time I want to find the function in terms of f of x plus 2, and then I want to subtract the function itself. So the first time around, I put an x plus 2 wherever I have an x. So 2 times x plus 2 squared plus 3. That takes care of this part. Now I'm going to subtract the function. So the function itself is just the function. So I put a minus sign in the front and I subtract the function. So this negative sign will be distributed. So x plus 2 squared is x plus 2 times x plus 2 plus 3 still. Distribute the negative, so minus 2x squared minus 3. This is going to be x squared. X times 2 is 2x. 2 times x is 2x. Let's see, x times x is x squared. X times 2, 2x. This 2x is 2x. 2 times 2 is 4. So combine like terms. So 2x squared, take away 2x squared, there's no x squareds left. 4x and 4x is 8x. And then my numbers are 8 plus 3 minus 3, which is just an 8. So that equals 8x plus 8. Step functions list multiple equations for different values of x. So whenever x is less than or equal to 1, you use the first function here. If x is between 1 and 5, you use the second function. If x is greater than or equal to 5, you use the 4x minus 1. So find f of 0. So we're using the first one because it's a 0. That falls under this condition. So f of 0 is 3 minus 3 times 0, which f of 0 is 3. Find f of 2. 2 is right here, so I'm going to use that one. So I plug in the 2 wherever I have an x. So it's just 2 times 2, so that gives me a 4. F of 10, that falls under that condition. So I'm going to use this one. So 4 times 10 plus 1, so 40 plus 1, I get 41. Domain. Domain is the complete set of all possible values of the independent variable. So our independent variable is our x. The range is the complete set of all possible resulting values of the dependent variable. That's the y. You cannot divide by 0, and you can't have an imaginary number, which means you can have no negative roots. So if f of x is equal to x squared plus 2, and I want to find the domain and range, so I think about all the numbers that x can be. There's really nothing limiting my x because I don't have a fraction, so I'm not going to create a divide by 0. I don't have a square root symbol anywhere, so I don't have to worry about this. So basically my domain is all numbers, all real numbers, because there's no limiting numbers. And then when I plug in all of these numbers, any number in the whole wide world, to x squared, I'm never going to get a negative answer because I'm always squaring it. So my range is going to be all reals greater than or equal to 2. When I plug in a 0 here, I get 0 squared plus 2, which is 2. So I really never get anything less than 2. Let's look at the next one. F of t is 1 over t plus 2. This time, because I have a fraction, I have to see what makes it 0, because I cannot divide by 0. So I need to find the number that's going to make the denominator 0. So t plus 2 is the denominator. So what makes this a 0? Well, when t is a -2, right? Because -2 plus 2 makes a 0. So I can't have t as a -2. So domain is all the reals except -2. Because this is the function never reaches 0, when you put numbers in for the t, you get all reals, but you do not get 0. So basically, when I plug in every other number for here, I'm going to get every number as an answer, except I'm not going to get 0 because the way I get a 0 gives me a divide by 0, and I can't have that. So my range is all reals that do not equal 0. This problem takes care of the root. So I can't have a negative under the root. So I have to find all the numbers that make this go negative. So first I'm going to find out what makes it go to 0. So 3 minus x equals 0. Subtract 3. Minus x equals -3. Multiply by -1, so x is a 3. So when x is greater than 3, the numbers under the radical will be negative. So the domain is all reals less than or equal to 3. I can have 3 as an answer because 3 minus 3 is a 0, and I can take the square root of 0, but I can't take the square root of a negative number. So when I'm using all of these numbers in the domain, less than or equal to 3, since I'm not generating any negative numbers, but I am generating a 0, my range is going to be all reals greater than or equal to 0.